Today, we are going to start with doubly linked lists. We talked about it briefly. We got some of the concepts or theory or whatever you want to say behind it and how this is all going to work. And this is based on the NIOF book, chapter 11 is where you're going to be able to find a bunch of information. But we're going to go with the lecture here. And I'm going to start out with what does happen if we need to move both directions. Okay. We're looking for something that has a predecessor and something that has a successor, something that comes before it, something that comes after it. In the world of integers, I say 6. What comes before it? What's its predecessor?
Five.
5. What's its successor?
7.
7. If I picked a char and I said capital B, I would know what comes before it and what comes after it. If I said capital A, what comes before it?
Capital Z.
Nope.
We're not going to do it that way. Okay.
No. What would come before it in the char world? Whatever would be ASCII code number. Blah, blah, blah. What is capital A? That's like 92 or something. Lowercase a is 65, somewhere along those lines. So it would be what comes before it. How many items are in the ASCII chart?
The at symbol.
The at symbol comes before capital A. Very good. What number is capital A? 92, 97.
65. You were right.
65. I was thinking that was lowercase. Anyhow, and these all have numbers and it's based on that number. How many characters are in the char data type?
255.
Close.
Damn.
You're off by 1.
Is it really 254?
Goes 0 to 255.
Oh,
So
okay.
it's 256. And what's so special about 256? 256 is the same as 2 to the
2 to the 8th.
8th power. 2 to the 8th power, 8 bits is 1 byte. Woo! That all comes together. If I had a double, 6.2, what becomes before it?
6.1.
No, I have no idea. Is it
Well, I guess it
6.1?
depends on how many decimal places you're using. It could be 6.1, it could be 6.19, it could be 6.199, it could be 60, and
So
so
we
on
don't
and
have
so
an
forth.
answer, right? It doesn't have a predecessor or a successor. What comes before true?
False.
What comes after true?
False.
False, yeah. Just like this goes 0 to 255 and then it wraps around. That would do the same thing. True, false, it would wrap around. In the old days, we used to have in Pascal this number, 32,768 up to 32,767. That was our integer in Pascal. This was integer. How many numbers would be here? 65,500, blah, 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 roughly. 65,000.
535.
And that actually equals 2 to the 16th power. 2 bytes. So all of this stuff a little bit deeper, starts to come into play as you keep going through computer science. And just keep that 2 to the 8th, 2 to the 10th is monster. That's that 1,024, and so on and so on. Yeah, not to be sidetracked. Something that has a predecessor. Well, we're looking at these nodes, and we want these nodes to have a predecessor and a successor. So if we were writing it horizontally like before, we're now looking at 3 pieces in the definition. A pointer called prev, a pointer called next. And if I was to write this out horizontally, it may look something like this. A couple of things extra here. Well, we know at the end, it's always pointing to null, right? But like up here with true and false, where else could I possibly make this point?
If you
Right.
wanted it to be a circular list, you could have it point back to the front.
Right, you could have this also point back to the front. So depending on what you need this for might dictate where this guy goes. Well, if I'm going to be going forward, I might want to also have a last pointer, one for first, one for last. In my definition, I'd make prev null, next null. Where does first points to this node, prev go? Where
Null.
does first, yeah, well, null, yeah. Depending again what we need it for, that may go all the way to last. But now you're starting to see we're building on things that we've learned. Oh boy, what if I wanted to do that? I really couldn't do this so much with an array, could I? Okay. Remember way back when you had no idea what I was talking about when I said we're going to do things the array way and we're going to do things the linked list way. Now all of a sudden it's starting to make a lot more sense. All right, so ba-boom. NIOF likes to take a look at it this way. NIOF likes to take a look at it where the node is vertically versus horizontally. It's whatever you would like to do. But here I have two nodes somewhere in my list. I don't know where they are exactly. Where are they exactly? So if I took a look at a full list here, this is what I'm kind of hoping to have at some point. We talked about this going to null. We talked about last, next going to null. It could do something like, where is first, next? Yeah, oh boy, what's he saying? What is first, next, next, Rev's value? Down here. Give me the answer.
8.
First, next, next, Prev. Yep, I believe it's 8. Cool. And again, I could do last, Prev, Prev's next, blah, 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 blah. To this point, I've discussed the concept, drew the picture. The next thing I would ask for is test data. Test data. Give me some test data of where things might be deleted. Give me a number.
5,
5,
12,
12,
And 15. Front, middle, end.
15. Stay with me.
And then something that's not actually in the list.
How about 3?
Yeah.
How about 7? How about 17? Me thinking about this test data hopefully is triggering alerts when I get ready to write this function. The function insert. I'm watching. I think quite a few of you are still drawing that linked list, so I won't go too fast. I'll just make some noise. Yeah, I got the picture now. I got the picture. Deletes test data. What did we forget? You can see it's written here if you're looking really close. I
Is
erased it.
empty.
Is empty. So when I come back up here, we got a little goofy. Do we really need to check 5? Remember, we're inserting, not deleting.
No.
No. 7 would be a good insert. Not 12, not 15. 17 would be a good insert. Did I accidentally say delete?
Yeah.
Oh, my bad. Well, now we have delete. 3, 5, 8, 9, 15, 17. I don't know that it would ever get to 17 because my loop would shut down after 15. Okay? I did it wrong. Probably because I said it wrong. All right, here we go. Do, 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 do. I want to do an insert. Let's see. I am going to have to traverse. So in order to traverse, I'm going to have to get a temp pointer. And temp pointer is going to start at front.
I have a question.
Yeah.
Could you explain just real quickly the difference between 10 pointer is equal to front and then front is equal to 10 pointer? Like what would that?
So right now, oh Nelly, right here, right now, we have front pointing to here. We have a variable called temp pointer. And when we initialized it, we probably said it's pointing to null, something along those lines. Now, if temp pointer gets the value of first, it'll go there, pointing to the same place first points to. First and temp pointer would have the same memory address if we did temp pointer equals first. If we did it the other way around, temp pointer was created and pointing to nothing. If we said first go to temp pointer, you get the value of temp pointer, it's going to point to nothing. So the order is going to have to matter so that I can keep track of where my linked list starts. Okay. Do 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 do. All right, so I need to create a new node. Because I want to get it in there somehow. I want and we've done this before. We've moved temp pointer to, where would I move it to?
Front next.
So temp pointer, yeah. So temp pointer is going to get it's going to get first, and then temp pointer is going to get the value of temp pointers next, and I'm going to keep moving temp pointer until when? Possibly
Until
two things. I want to
Until the
keep,
temp pointer's value is greater than the new node.
well, that
If
would
we're
be
starting from the front,
you'd be starting from the front, and I think what you said would insert it in the second spot.
in between 5 and 8.
How would I get it to here?
You would have to check the previous node to see if you're greater than it, and the next node to see if you're less than it.
Jack's saying greater than 5 and less than 8. Do I need all of that?
If you're checking the previous node, which would be 5, if you're checking before you advance temp pointer, because we did something like this when it was a singly linked list, you compare the value of the previous node or the active node in this case, which would be the 5, to the new node. 5 is less than 7, so it's not greater than 7. So you move temp pointer to next, and then you check 8, which is greater than 7, so you would insert it there.
Pointer is pointing at 2 right now. Okay? Temp pointer, this is the first one. So we're going to talk about that later. So now I'm up and moving. I'm only worrying about inserting to the middle. So will I insert it here? I'm hearing that it's got to be greater than this or less than this. Do I insert it here? Do I insert it here? How would I know to insert it here? Would just be based on the 8. It would just be based on the 8. I just know I haven't found the number bigger yet. So I'm going to keep going until I find a number bigger and put it in the middle. So right now we're saying temp pointer is going to be pointing to here. Right there. And this is the advantage of a doubly linked list. So we want to move temp pointer to location before. Well, in this case, we went to location after, and that's fine. Again, there's going to be different ways to write this. Move temp point. So I'm going to keep going until temp pointer's value is greater than new node's value. All right. So right now, temp pointer points there. Tell me what to write. This is for real stuff now. Oh my. How many pointers have to be moved?
You have to move 4.
Excellent. 4. Is order going to matter?
Yes.
Oh, yeah. Oh, yeah. So this guy has to go up there. This guy has to go. Oh, geez, hooey. Hong Kong fooey. I'm going to pause the recording and give you a minute to think.